This video is an introduction to Control Solutions Babel IoT gateways. These gateways fall into the Internet of Things category because they go beyond just being a protocol converter. These gateways can be used to connect Modbus or BACnet devices to Amazon Web Services IoT core and turn any Modbus or BACnet device into a thing on the Internet of Things. From there, what you can do with Amazon Web Services is limited only by your imagination. You have immediate access to notification services, database services, analytics, and even AI. The Babel IoT gateways can also be used as standalone data loggers or remote monitoring devices without any connection to the cloud. All of their data logging and alarm monitoring capabilities are supported internally. You can use the IoT gateways for either cloud or non-cloud applications, or both at the same time. Here's a block diagram showing how the IoT gateway fits into the picture connecting your Modbus devices to the Amazon cloud. The Modbus devices connect to the gateway, and the gateway publishes data via internet to the Amazon cloud. Within the Amazon cloud, IoT connects to other services including databases, analytics, notifications, AI, and so forth. The text message illustrated was generated by Amazon Simple Notification Services from data published by the Babel IoT gateway, and the graph shows data collected by the IoT gateway and published to the cloud. The block diagram of the BACnet version is identical in terms of how things work. In this case, we simply connect BACnet devices instead of Modbus devices. The protocol used by the Babel IoT gateway to collect data from the local devices is obviously different, but the protocol for sending data to the cloud is identical between Modbus versus BACnet. The Internet of Things, whether Amazon, Google, or others, is based on a protocol known as MQTT. It uses JavaScript object notation as illustrated here. The protocol uses a subscribe and publish method where you publish data you want to share and subscribe to data you want to obtain. This is what the data looks like when communicated between the Babel IoT gateway and the cloud, and looks the same for both Modbus and BACnet versions of the gateway at this level. The MQTT protocol is universally recognized. However, each MQTT-based IoT cloud has its own set of rules referred to as an API, or Application Programming Interface. Therefore, while the definition of an MQTT broker or server is generic, the actual implementation is always somewhat unique. Control Solutions chose to go with Amazon Web Services, or AWS, for its initial offering, because AWS offered the greatest selection of features at a most affordable price. You can get started with Amazon Web Services Internet of Things for free. Your first year of AWS IoT is free and quite reasonably priced after that. Here's a block diagram of how data is flowing inside the Modbus version of the Babel IoT gateway. The Modbus engine is acting as a Modbus master and/or slave collecting data from Modbus devices. If acting as a Modbus client or master, you set up polling of registers and other devices using simple templates in the IoT gateway. If acting as a Modbus server or slave, other devices like a PLC can write to Modbus registers within the IoT gateway. On the IoT side, you use simple templates to specify criteria for publishing data to the cloud, and then according to your rules, the IoT gateway will publish data to the cloud and subscribe to data from the cloud. The BACnet version works the same way, with the only difference being the BACnet engine in place of the Modbus engine. If the BACnet engine will be acting as a client, you use a simple template to tell the IoT gateway what properties to read from other BACnet devices. If the BACnet engine is acting as a server, other BACnet devices can write to the BACnet objects contained within the IoT gateway. The BACnet engine can be both client and server at the same time. On the IoT side, you again use simple templates to specify criteria for publishing data to the cloud. Then, according to your rules, the IoT gateway will publish data to the cloud and subscribe to data from the cloud. The Babel IoT gateway can also provide standalone remote monitoring with local data logging, simple template setup of log parameters, local alarm monitoring, freeform notification message templates, secure email client, automatically send CSV data file as an email attachment. The Modbus version has both Modbus RTU and Modbus TCP, and the BACnet version has both BACnet IP and MSTP. There are two ways of going about data logging with the Babel IoT devices. One is via the cloud. The other is to log data to local CSV files and have that file emailed to you periodically. Selection of data points is pretty easy. Every Modbus register or BACnet object shows up in the list. Simply check off those registers or objects you want to log. Once you have selected which registers or objects to record, a simple template is where you decide how often to record them and when to send the log file to yourself via email. Alarm notifications are triggered by event rules that have a threshold and optional qualifications, including hysteresis and minimum on and off time. And for each event rule, you also decide which message template to use and who to send it to. Here we see an example of an event rule, as well as a notification email that was sent as a result of this event. Once an event is triggered, notification messages are constructed from free-form templates that include variable names to incorporate real-time data. You can use an external text editor or the built-in editor to create whatever text message you like, and optionally include any of the available variable names in brackets. These variables are replaced by real-time data at the time the message is sent. Scheduling is done in a very generic and simple way. A register or object you select will change value according to a schedule you provide. From there, you can use the client to write that register or object to some other Modbus or BACnet device to cause action according to your schedule. The weekly schedule allows you to specify that something should happen on a certain time of certain days of the week. It can be one day, multiple days, or every day. Sometimes you want a weekly schedule to not apply on a holiday, or maybe you want something to happen only on a holiday. The holiday processing in the scheduler allows exceptions to the weekly schedule. The scheduler also provides the opportunity to schedule something to happen just one time on a given day or days. Instead of day a week, specific dates and times are provided, and other than selection of day, the on-demand scheduler works the same as weekly. This wraps up our general introduction to Control Solutions Babel IoT gateways. There are a number of additional videos you may view related to the particular gateway, Modbus versus BACnet, and also additional videos related to Amazon Web Services Cloud versus standalone use.